Hello YouTubers, this is Coconut Cowboy back with another high quality production, and we're going to be working on a trailer today. This is actually my trailer. I built this in high school in ag mechanics through the FFA, and it's just a little 12-foot utility trailer, and it's seen better days. As you can see, needs a paint job. That might be on the list depending on how ambitious I feel today. I need a place to put a spare tire. That might be on the list today too. Gonna add some more D-rings. Maybe a little body work. Pretty cruddy. I added some rings not too long ago. A little higher quality than what I have. Got the tailgate on it that drops down. Did some work on that not too long ago as well. If you've never built your own trailer, I highly recommend it because they are 10 times sturdier than what you can buy. It's going to cost you a little more, but there's a reason behind that. So we're starting out right here. I think I'm going to grind that down, grind the rust and the dirt and the paint and all the crap down. Put a D-ring there, and then put one on the other side too. So, stick around. Okay, so got it laid out, got everything ground. These are galvanized D-rings. They're from Home Depot. I can try to find some links for you guys for these things. They're really cheap, that's why I have them. They're galvanized, like I said. Gonna go about there. And there's a lot of misconceptions about welding galvanized. We'll get more into that later. Grinding wheels I'm using. Everybody asks what you're using. So Cubitron 2s from 3M. Got a hard wheel and a flap disc. These things are great. And pretty much anything with 3M is good, but you're gonna pay a little extra for them. Machine today, ESAB Rebel 215 IC, and I'll have to do a review later on that guy. So far so good. I really haven't had a whole lot of time to play with it. There's fingers in the camera, awesome. But a bunch of different settings, MIG, or SMIG, sorry, Smart MIG. Normal MIG, flux core, stick, and lift TIG. Haven't got into the TIG yet. Like I said, we'll do a review on that later. So we're going to run 90 amps, 51 volts. That's kind of right in the middle of where they recommend. And if you go into this, oops, and the information, they have a bunch of settings for you, at least baseline settings. So we're going to be running 330 seconds, 7018 again, and the range is 65 to 100 amps. So we're kind of in the middle of that. Alright guys, I got them tacked on, ready to be welded. I've actually got the other side welded already. I hope you can hear me over the noisy fan of the ESAB. That's one complaint I have about that thing, is the fan doesn't shut off till it's through with its timed cycle or whatever the hell they worked into that. So these are originally designed to be bolted on, and I'm sure there's somebody out there who's going to say you're reducing their strength by welding them, but that's fine because they're only rated for 1,600 pounds and some change for load limit and 5,000 pounds for brake strength, so I'm not too worried about it. And if they break, I'll stick them back on again. So I got that one stuck on there. That will work, and I'll weld this one up and get back to you I still don't have a filter shade for my fancy filming equipment phone here, so you'll have to pass on seeing the weld. But okay, tubers of you, I finished up the random project from the neighbor guy, and I'm back on messing with the trailer here. So as you can see, this cap here on this 2x6 piece of tubing has a nice big crack in it. It's not going to affect the structural integrity of anything, but I don't like seeing a crack in it. It lets water get in, and then water freezes and expands and blows out other tubes and whatever. So I'm going to grind that out and get it patched up. Since I'm still hooked up with my MIG gun on my Rebel, I'll go ahead and use that and then go back to stick. So stick in there. Okay, got everything ground out. Best way to stop a crack is to drill a hole in front of it. So if it keeps cracking, it goes to the hole, stops the crack. I didn't have a tool to get in here close to the stake pocket here, so I ground it out the best I could and added another hole in there. But we're all ground out. I probably should drill another hole down here. I'll do that, and then I'll go ahead and weld it up. So go figure, I ran into a problem. When I drilled that bottom hole, all that came out. So you can tell there's been water getting in there. And I crawled underneath and looked around, and I never added drain holes to this guy. So I did that. I drilled 3 holes in it, one at each end and one in the middle. Try to reduce any kind of buildup of moisture from any leaks. The holes in the center and on the other end didn't have this nasty mess of junk come out, so I think it was just this side leaking in there from the crack. Hopefully it's not rotting from the inside. That would be a terrible thing. And you can hear the fan on that stupid ESAB going. Okay, YouTube, we are back with the trailer modifications project. It's been about a week now. I've been busy doing that thing where you have to go in every day and earn a paycheck and whatnot. Get out of here, dog. Shoo. So, really want to get the spare tire holder project done. Get the thing on the trailer, and then I can get it painted and get on with my life. So, I kind of have it ratchet strapped up just so I can kind of get a measurement, figure out what I'm going to do here. So, if you can hear me, great. If you can see this, great. I'm using a new to me camera and a tripod this time, so hopefully I'm not making everybody sick. The plan is, working around the tripod now, to have a piece of angle iron, and this is, we're going to call this top ISO view, kind of. Forgive my drawing skills. That's my piece of angle iron. Wow, that's nice. And a piece of tubing coming up, and then another piece of tubing, and this is going to go to the side, but it'll actually be straight at me, straight at you. And then I'm going to mount my plate here with the bolts, and that's where the spare tire is going to go. So, did some measuring. I got it written down here. You probably can't see that. So I need to be 9.5 tall. And that'll put this center of that tire 8.5 inches right off the top of the trailer bed, which seems to work out to be a pretty good height. So let's do it. Okay guys, so I'm used to working in a 3D modeling environment, and I told a buddy this who started doing the same thing. He's been working in Audodesk Inventor, which is what I use on a daily basis. It is very hard to transition from being able to build stuff right in front of you on the computer and see if it all measures up, fits up, and everything works good. And I'm trying to transition back into where I can build stuff just by looking at it and getting an idea in my head and fitting stuff up. So what I did here is I used the old engineering strap, it's a ratchet strap, and strapped the tire onto the trailer just so I can kind of get an idea of dimensions and what needs to happen. I don't want anything rubbing back here. The lighting sucks in here, I apologize. I don't want it rubbing on this. Obviously it's strapped to that, so it's touching that, but I'll push it out about an inch. And then the way I made this trailer is I've got 4-inch channel iron connected to 6x2 tubing, and then I've got a piece of 3-inch channel iron going back to the spacer tubing that the axle's welded to. So everything is connected to the tongue, so it's stronger that way. And I'm going to come off of this piece of 3-inch connecting channel. So that's kind of how I set it up, just to pull measurements and kind of get an idea of what I wanted. But without the software, this is what you sometimes end up doing. Cardboard cutouts. I've seen elaborate machines drawn on concrete floors and then built from that. So just because you don't have the latest and greatest of softwares and technology, do what you do with what you can. Okay, so here is our angle plate with the piece of tubing on it. So we're going to kind of do a little level lesson here, just because I've seen a lot of guys out in the field and in the shops and stuff that don't really understand the basics of a level. So let's try this out here. So our plate's not level. I don't know if you can see that. If I can focus, sucks. But before we even try to level the plate, we have to level what the plate is on. So trailer isn't level, and there's a lot of edges here to try to figure out where the level's coming into play. I think we'll just go off of this, since this is the main frame angle here, and if what you're working with isn't level, then what you're trying to level on the workpiece isn't going to be level. Because the level levels to the world, if that makes sense, and then that has to be level for that to be level. Makes sense? Great. Let's jack up the trailer and get her level. Okay, so trailer getting closer. That's pretty close too. Trailer's level. Piece is pretty damn close to level. So, just because you stick a level on something and make sure it's level doesn't mean it's level with everything else. You got to start out with your base material, base project, whatever you're trying to level to. Otherwise it doesn't make sense. So now that our angle plate is level, I'm gonna see how this guy is for level. Let's flip that guy around. And you can't see that, which is fine. But it needs to come over just a little bit to get level. So I used to weld pipe, hydronic pipe, 60-10 root, 60-10 cover pass, and everything was done with a level. So you had 2 pipe jacks, and you would level your pipe, and then your fittings coming off of it would be leveled to the pipe. So everything was square and good. And that's the way I'm going to do this. I'm going to tack on this side, on the left side, to pull the whole thing over a little bit and get my level. And then I'll come on the front and make sure it's good, and it actually needs to come towards the camera, towards you guys. So I'll put a tack on this side and bring it this way and then weld around it. So that's how I'm going to level my tube coming up. You could also stick a square on there. I just like doing it this way because that's what I'm used to. And the squares are just as good most of the time. Cross measuring is probably going to be your best bet. So that's the plan. Alright guys, let's see what we can do here. The old 7018 on the ESAB. And she pulled her almost right to where she should be on level. So, got the tack right in the center. And I don't know if you guys caught it, but I forgot to check my level on the angle this way, which it's just a fuzz on the line here. So, and that's pretty much where that guy's sitting as well. So, I'm going to tack this side. And the front. And I'm actually going to take this off to weld it out complete, just because I want to be able to weld the backside here. See if she moves. Alright, so I got our top piece on here. I didn't put that on the fancy drawing. It's about 9 inches, and then the plate is going to be 3/8. So 9 3/8 coming off the front edge here. Off the back edge, sorry, this is 7. Get it tacked and then check for square. Okay. Where squares at? That's not too bad for just eyeballing right off the bat. I'm gonna give it a little pop here. Yeah, that'll work. One more tack. Just to keep everything where I want it. Alright. So we're going to get this cleaned up here a little bit. Some of the slag up there. Don't want any slag in your weld. Little battery powered grinders work great for running a wire wheel. And let's put some welds on this. Using the ESAB 215, I see again. 3/30 seconds. 7018s. Actually, I don't have a tack on the bottom of that, so I don't want to weld that just yet. And my camera doesn't look like it freaked out too much from the welding, so That's a good thing. Find my chipping hammer. So guys, I'm using 7018 rods because I need the practice. It used to be structural unlimited with 7018, and I haven't used it in years, so this is kind of a refresher course, practice, get back into the whole deal type of thing for me. I've been getting porosity on starts. It sounds, from what I can figure, is just that it's my initial start. I must be pulling back a little bit and I'm long arcing. And that's where the porosity's been coming from, but I don't remember having that kind of problems back when I was running this stuff all the time. Yeah, a couple little bubbles in the slag on that one. Might have a little porosity. Ah! Look at that. Nice. Cool. I'll finish welding it out and get back with you. Okay guys, we're just heating up the plate. We got to heat up the plate again because we're not qualified to run 5/16 thick material on 110 with the old ESABer. I've been working on this a little bit. It's getting toasty, but we're getting there. So even though you got thicker plate than you're supposed to be welding, you can always preheat, bevel, do other things to get by. Oh yeah. Now I'm not going to get rosy red hot with this torch, but anything helps. So. The plate is 5/16, probably hot rolled, pickled and oiled. Made that at work. See what they're going to charge me for it, but programmed it in Audodesk Inventor. Program I was talking about earlier. Cut it on a laser. Etched where the tube went, so I didn't have to measure anything. Eyeball it as close as you can to center and call it good. Good. That's a welder. And I had a tack break, so I'm going to re-tack. And then if I remember right, because I've been off screwing around since then, everything needs to go that way. So I'm going to put my first weld back here. And hopefully it pulls everything over a little bit. And if not, it's a frickin' spare tire holder, so whatever.
So as you weld, the plate's going to get hotter and hotter, which helps you out more and more the thicker the material is.
Excuse me. I can't even reach that. Bueno.
Hey guys, had to switch cameras. I'm out of memory. I got the bolts on. These are grade 5 big R bolts, you know, because they're green. Apparently that makes everything grade 5. I got them welding on the back, 2 welds. Ground all the green stuff off. I'm not afraid of zinc, but I'm afraid of whatever that green stuff is. Welding in here, the reflective stickers here, I thought I had them ground up high enough, and the schmoo started dripping down into the welds, and so I got about a good inch on this side. My well, that looks cold in the video, but my vertical up actually came out pretty nice for not doing it for so long. And I did the immortal sin of using rebar, welded it. That's going to be my gusset, just because you can't make something without frickin' rebar. I got a little gusset on the bottom there too. 2 welds on the bottom. About 2 inches of decent weld on this side. More of the stuff started dripping into the weld. You can see the plate that we were heating up, first, second, third, fourth weld, the heat affected zone on them. All the tacks have decent weld or heat affected zones on them as well. So I think that's okay. The plate actually warped a little bit, so that tells me it got good and hot. If I was worried about the warpage, I would have bolted a second plate onto it, thicker, just as a heat sink and to keep everything from moving on me. And if you don't know, that dark coating there, you can see I ground over here, but that's oxidation from the processing, the laser cutting process. And actually, if you go and paint that, it will not stick to it. So I'm going to grind all that off. And I'll show you the tire on here. There you have it. Tire fits. Only got 2 nuts on there. Need to find like a nylock nut or something that'll keep it from rattling off. I got plenty of space in between the rails and the tire. I'll try to find my tape measure here because we planned for 1 inch and it looks to be a little more. Sorry about the wobbliness. Hopefully you don't get seasick. Yeah, it's about 1.25 inches, depending on where you measure. So that's not too bad. Came out a little thicker, but that's fine. So yeah, came out good. Next step is to start sanding and painting this guy. Yeah, that's better than sitting on the floor in my shop. Thanks for watching. Subscribe, comment, rate. Just watch the damn video. Thank you.